Remove the 24 bolts that are holding the upper and lower final drive assembly to the differential. Using a lifting device and crane, move the final drive assembly to a safe spot where it is out of the way. Following that, use the crane and lifting device to remove the differential from the lower final drive assembly. You may also require assistance to help remove and place the differential. Place the differential in a spot where you can safely work on it.
To remove the input yoke, there will be a castle nut and an O-ring holding it in place. After removing the castle nut, use a pair of picks to assist in removing the O-ring. The input yoke should slip right out. After removing the input yoke, the oscillating support should also slip right out. After removing those pieces, remove the 15 bolts holding the input shaft housing to the differential case. Once the input shaft housing is removed, use a press to press out the input shaft. Remove the 6 bolts on the bearing quill to reveal the bearing cup and cone. To remove the differential output bearing cup, weld a bead along the bearing cup and allow it to cool. Effectively, by doing that, when the bearing cup cools off, it shrinks, which makes it easier to come out. To install the differential output bearing cup, the easiest method would be to chill the bearing and set it in place. Essentially, the cooler temperature would cause it to shrink, so it would be easier to place, and when it returns to room temperature, it would be in there tight.
To remove the differential output bearing cone, use an appropriately sized puller that will allow access to at least 2 sides of the bearing. You can use the output shaft as an anchor for the puller to leverage against. To reinstall the differential output bearing cone, the easiest method would be to chill the bearing. By doing that, it would shrink the inner race to allow it to go on easier. If it doesn't want a seat, slight taps on the inner race with a dead blow hammer should do the trick. You can adjust the end play for the bearing on each side of the differential by shimming the bearing quill. End play has many different purposes. For example, as bearings heat up, they expand. This end play adjustment will make up for the expansion. You can adjust the pinion cone point by adding shims to the pinion input shaft. These adjustments will affect the contact patch between the pinion and crown gear.
By shimming the input shaft, the coin point contact patch will be affected. As a result, the shims will control where the tooth contact patch will be. Apply the paint to the contact face of the gears to see where the gears are contacting each other. The area that is most strongest and effective in transferring torque is the middle of the tooth.
To reinstall the input shaft into the input housing, insert the shaft into the housing. Since the shaft is press-fitted, inserting the shaft will not seat it into the inner race of the bearing. A few taps with the dead blow hammer should assist in seating the shaft into the inner race of the bearing. If that doesn't work, utilizing a press to seat the shaft into the bearing would help. This differential works by getting its power from the output of the transmission. From there, it is connected to the input yoke, which is splined to the input pinion shaft. On the end of that shaft, the input pinion gear will rotate, and as a result, it will also rotate the crown gear. Subsequently, the output shaft, which is splined within the differential housing, will also rotate, and on the other end of the output shaft is a sun gear splined to it. That sun gear outputs to a planetary gear set within the final drive assembly.